to spend today doing arithmetic sequences, and we'll talk about what arithmetic means and what the word sequence means. And then tomorrow we'll do geometric sequences. So we'll stick with sequences, but we'll go to geometric, and we'll talk about what that means. And then on Monday we'll do arithmetic series. So we'll already know what arithmetic means, but we'll have to talk about what is series now. And then we'll do a geometric series. And those are the four main concepts. So anytime you read a problem at the end of this chapter, I'm going to ask you two things. Is it arithmetic or geometric? That's going to be the first thing you have to identify. And then I'm going to say, is it a sequence or a series? Because these are the four formulas that 3 of the 4 are given on your reference sheet, and the 4th one you just have to memorize. Okay? So that's the scope. So let's talk about arithmetic. Oh gosh, that hole punched out. Blank terms of an arithmetic sequence have a, I think it just says the. The terms of an arithmetic sequence have a common difference, is what it's going to be called. And that's going to be notated by a D. And a common difference is nothing more than what are we adding each time. So arithmetic patterns are the ones where you add 5, add 5, add 5, add 5. Got it? And in that case, the common difference would be 5, positive 5. Here's a sequence. What are we subtracting? Subtracting 5, so the next 3 terms would be negative 12, negative 17, negative 22. What's the common difference? Negative 5. D equals negative 5. So, now jumping to notation. Given the first term, see how we're given the first term, a sub 1 is 1, so the first term is 1. And given the common difference of a half, find the next 4 terms. So a sub 1 is 1. A sub 2 would be what? No. The common difference is a half, so that's what I'm adding each time. 1.5. And then the third term would be 2, and the fourth term would be 2.5, and the fifth term would be 3. It said the next 4 terms. I already had the first, so the next 4 would put me through the fifth. Good? Good, good, good. The first term here is negative 2, and we have a common difference of negative 3. So, Jason, what would the second term be? Very good. Jack B, what would the third term be? Negative 8. The fourth term, Eric? No. My common difference is negative 3, means I'm subtracting 3, subtracting 3, subtracting 3. Very good. And the fifth term, Lucas B. Very good. Nice job. Okay? Pretty straightforward. This is a nice pattern. It's because it's easy to pick up on. Okay. So recursively, and this is what we did yesterday, and you would figure this out on your own with or without me telling you this, you would get to an nth term by taking the previous term, a sub n minus 1, and just adding on that common difference, right? You were doing that already. This type of format, though, has an explicit. Do you see how, and here's the explicit formula that I'm giving you that will also be on your reference sheet. Do you see how it does not use a subscript of n minus 1? It has an n minus 1 in there, but it's not a subscript. So that's how you differentiate between a recursive and an explicit. What's nice about an explicit is I can just jump to the 100th term if I want. With a recursive, I couldn't do that. I would need the 99th to do it. I would need the 98th to get the 99th, and so on and so forth. So in this particular one, if a sub 10 equals 8, what's your n value? What term did they give us? 10. So n is 10. So that would go there. A sub 10 is 8. So this would say A sub 10, but we would replace it with 8. You follow that? The common difference is 3. And so what variable would we be left to figure out? The first term, right? The 10th term is 8. The first term they didn't tell us. N, because they gave us the 10th term, N is 10. And D is 3. So we're just going to solve for the first term. 8 equals A sub 1 plus 9 times 3, 27. Agreed? Subtract your 27 over. And A sub 1 equals 8 minus 27 is, it would help if I did not take the natural log of that, negative 19. So they want us to find the first 5 terms. So there's your first. And now the rest should be a breeze because I know the common difference is 3. Plus 3, plus 3, plus 3, plus 3. So Owen, what's my second term? And my third, keep going. And my fourth, keep going. Excellent. So that's the first 5 terms. Good? Okay, so in the next exercise, A sub 1 is 12, A sub 5 is 20. Find D. Okay, so what's going to go in where? Tess. Do we know what A sub n is? Let's go term by term. Do we know what A sub n is? We do. We do. 20. A sub n is 20. And so what's n, Tess, while we're at it? 5. Right? Fifth term being 20. So n is 5 and A sub n is 20. And we don't know the common difference. They're telling us to find it. So the only thing we have left to plug in is what is A sub 1, Tess? 12. So that gives us 20 equals 12 plus 4D. Subtract 12 from both sides. 8 equals 4D. So D equals 2, and we're done. Any questions? Okay. Flip us over. You know what? Do yourself a favor. Rewrite the formula at the top so we don't have to keep flipping back and forth. A sub n equals A sub 1 plus n minus 1 plus k. No. Plus d. Sorry. Why did I say plus k? I was thinking like transformation. Shifting up, shifting down. Listen. This is what happens when they put it on the reference sheet. Even your teacher doesn't memorize it. Why would you? All right. So A sub 3 is 8. So tell me what you're going to do with that. Alexa, what would you plug in for what? Good. N is 3. That's troubling. Because we don't have D, right? And we don't have A sub 1. But they did tell us something else. So maybe we write a second equation with that. If A sub 11 equals 12, we could let A sub n be 12. We still don't know A sub 1, but we do know that n was 11 minus 1 times d. So what would you refer to this as? This is a what? When you have two equations with two variables. System. And can we argue that everything's already lined up So let's maybe just do elimination, right? And I already have the same coefficient in front of a sub 1, so same sign, add or subtract. Subtract, subtract, subtract. So 8 minus 12 is negative 4. The a sub 1s are gone. 2d minus 10d is negative 8d. And so what's d? 1/2. Once you know d, you can go back into either one of these and find a sub 1. So 12 equals a sub 1 plus 10 times 1/2. 10 times 1/2 is 5, right? So subtract 5 from both sides, and there's your a sub 1. A sub 1 equals 7. I've found the two missing pieces of information. Good. A recursive formula. We have 3 options. Let's just start with the second one. We know that d is 2, and we know that the 15th term is negative 10. Truthfully, you could make your recursive formula, give the 15th term, and then to get any nth term, you're going to take the term before and do what to it? Not multiply, add 2. Because this is just take the term before and add 2. I will say, though, that if this is ever a multiple choice, it's probably going to give you the first term and then tell you to take the previous term and add 2. So in order to do that, we would have to find the first term. Are you with me? And you're going to find the first term by going back and using your information in this formula. So a sub n would be negative 10. A sub 1 is what we're on the hunt for. The nth term that they told us was 15, so n is 15. And d is 2. So use this to find a sub 1, and then once you have that, this is the recursive formula that a multiple choice would probably give you. Okay? Even though technically you can give any starting term if it's open response. Good? Okay? Last one on the bottom, because it's a little bit tricky. They're telling us that this is an arithmetic sequence, right? So what am I adding to get from here to here? 3x minus 1. You're adding the 3x and subtracting 1. What are you doing to get from here to here? Adding x and adding 3. Do you see that, Owen? Okay. Now, those don't look the same, but if it's an arithmetic sequence, they need to be the same. So set them equal to each other and solve for x. So if we solve for x, and I'm just going to do this for you, you're going to get 2x equals 4, so x will equal 2 after all is said and done when I solve that equation. And then take a look. If x is 2, what's the first term really? What's the second term? 4 times 2 is 8. 8 minus 1 is 7. Hold on. 6 times 2 is 12. 12 plus 2 is... Did I do something wrong? This one was 9? Oh, yeah. Yeah. So what am I adding each time? 5. And then you could go on and find the fourth term. Listen, these have, there's a lot of work that goes into it. If you start to cram things onto these worksheets, you're going to get very confused. Don't worry about saving trees, okay? Do your homework on a separate sheet of paper and staple it. Sometimes we can be environmentally conscious, but not if it takes away from our math accuracy. Absolutely not. I think that's right. Yeah. Have a wonderful day. Thank you.